clients are just poultry farmers, it can be broilers, it can be laying hens, or it can be broiler breeders. So a bit of an overview of what we will do today and a bit of what we will do tomorrow. Today I will tell you something about parent stock and the rearing period and what we do and what we want to achieve with vaccination. And afterwards what you can do in monitoring the health status of parent stock. Then tomorrow we will discuss more about the effect of this and namely in the day-old chicks. And then there will be some more about the parent stock and about the influence of their health status, and then some common health issues, but that will be something for tomorrow. On the side of my slide you can see a small pic about how we move from grandparents to parent animals to broiler chicks, and eventually we produce broiler meat. And it's important to realize about how all farms and sectors in the poultry sector are linked to each other, and how we move animals from one farm to another farm. And that's very important to realize when we want to control diseases and we want to prevent diseases from spreading. It's given that we have a sector where we move animals and we have risk in spreading diseases as well. So at first, I will start to talk about vaccination and about immunity. When we are rearing parent stock, there is a lot of vaccinations that are administered. And we have two goals to this, and this is the main two goals that we will discuss today as well. We vaccinate parent stock to serve two purposes. The first purpose is to protect the flock itself. So we want to keep a broiler breeder farm with different flocks of parent stock. We want to keep them healthy, and that's why we vaccinate these animals. But there's also a second goal, and this second goal is to protect the progeny. We want to produce healthy broilers and have healthy offspring. And to achieve this goal, this second goal, to protect the progeny, there's two main goals, I can call them. And first of them is to prevent vertical transmission of diseases from parent stock to day-old chicks. And on the other hand, we want to produce a best performing broiler by giving it maternally derived antibodies. Here's some of the vaccinology principles. When a bird or a mammal is vaccinated, a small part of the disease is brought into the animal. So we bring a small part of the antigen via the vaccine into the muscle or another organ of the animal. And in these organs, there's dendritic cells, immune cells, that will recognize some of this antigen. They present it on the surface of their cells via MHC class 2 proteins, and afterwards it will move into the body of the bird and will encounter T helper cells, and by connecting this to these T helper cells, there will be B cells formed. And these B cells, they will proliferate, and eventually these B cells will maturate into different types of B cells. We have the B memory cells, which are very important in long-term immunity. And then there's plasma cells formed, and that's why you see the red circle around the plasma cells. They will eventually produce antibodies, and that's what I told you just right away about the antibodies that we want. So we bring a vaccine into an animal, and then there's a whole chain pathway of immunity reactions, and antibodies are formed. And quick remember on vaccination, we have different types of vaccinations. We have live vaccines and we have killed vaccines. We can administer vaccinations for only a single time, but we can also booster vaccines. And also this is nicely given in the graph. You can see that when we expose an animal to an antigen for the first time, that there will be a primary immune response. And you can see that there's a low response, a moderate response, an increase in antibodies. And this is mainly low affinity antibodies. But when we booster this animal by a second exposure to the same antigen, because of the memory cells I just showed you, there will be a far more higher response. And the secondary response will also produce more high affinity antibodies. These are antibodies that are more specific to the pathogen. And then there's different ways of vaccination in poultry. In poultry, we have a lot of different ways of vaccinating animals, like injection, drinking water, wing web, eye drop, spray, and mist. And you have to take into account if a vaccine is a live or a killed vaccine, if you want to do a single shot, if you want to booster it. And that is all very important information in the way of administration of your vaccination. Then, I was talking about the antibodies because they are very important in producing progeny with maternal-derived antibodies. In other words, antibodies can be called immunoglobulins, Igs. And there's 3 different types of immunoglobulins. The first of them is IgA, and IgA is mostly found in mucosal surfaces, so on the eyes and the beak of the bird, and also saliva contains high amounts of IgA. So IgA is very important in the protection in the first barrier of defense, as it's in mucosal surfaces. Then there's IgM. IgM is very important in early stage immunity. It increases very fast, but unfortunately it has a short survival, and it decreases also very fast. And then there's a third one, that's IgY, and this is similar to the mammalian IgG. So this is a different type of immunoglobulin, and it's specific for birds, for chickens. The IgG1, you can see it on the picture, is somewhat more bigger than the IgG that we can find in mammals. These IgYs are very important in the long-term immunity of the bird, and they are mainly produced after the booster, after the second exposure of the antigen, and these are more highly specialized immunoglobulins. So to sum up, we have 3 different types of immunoglobulins that can be produced after vaccination and which can produce the bird itself. But what also can happen is that they are transferred to the egg. And this is very important in producing healthy broiler chicks, hence transfer their antibodies to the egg. And that's why we call them maternally derived antibodies, as the chick, when they hatch in the hatchery, they already have a bit of protection that they received from their mother. And you can see within the egg, within the yolk, it mainly contains IgY, and within the albumin around it, IgA and IgM are more abundant. 30% of the bird's IgY is transferred to the progeny. So this is very important to realize that that's quite a lot. A parent animal, it will pass 30% of the IgYs to its offspring. So we want to achieve high levels of IgY in the parent stock so that they can transfer these via the egg to the day-old chick. But it's important to realize that variation is in this case possible. In this graph you can see 2 different breeder lines, and there's a difference in the amount of antibody that is transferred to the yolk. This is not always the same, and there's a lot of genetic differences in the amount of antibodies that is transferred via the yolk to the day-old chick. So realize that variation is possible. Then here's another graph. I want you have to imagine this is a young animal, and this young animal is the red line and the yellow line. To produce these antibodies for itself, it will take some time. It needs time for the young animal to create a good immune response for itself. So in the first days of its life, the young animal is very vulnerable for disease. And that's why, that's the big blue line that you can see, it's important that there's maternally derived antibodies, as these antibodies that come from the mother form a good protection for the first days of the life of the young animal, and when they start to increase, then the animal is able to produce its own antibodies. So for the first days, it's very important that a young chick reaches these antibodies like IgYs or like IgGs in mammals, it's on the picture, in their early life. So now you know something about vaccination and about the production of antibodies, and you know why they are important. And why are they important? Because there are a lot of different diseases. And this is an example, and I can imagine this is a bit hard for you to read, But this is an overview of all the vaccinations that are given to a broiler breeder in the rearing period. So the broiler breeder is reared for 20 weeks, and these are all vaccinations, that's also given with E, and some of the sampling for monitoring, but we will come back to that later. And somewhat more simplified, I have it over here. D is saying the day of life, so a broiler breeder is on the first day of his life, vaccinated with a wristband cell, that's Merrick disease, then recombinant vaccine also for Merrick, but also for infectious bursal disease. Then it is IV infectious bronchitis virus vaccinations and coccidiosis vaccination. That all happens on day 1. And then afterwards, in the entire rearing period, we vaccinate against salmonella, that's very important, but also against diseases like chicken anemia virus, avian rhinotracheosis, avian encephalomyelitis virus. And this is all viruses that we really keep in mind are 2 goals of vaccination. We want to keep the flock itself safe, and we want to produce healthy offspring. So a lot of vaccinations are administered to broiler breeders. So our first mission is to protect the progeny. And this mission, I told you that hens are vaccinated against different diseases, and it's mainly important to have good protection in early life. But it's depending on the type of disease for how long protection will last. So for Newcastle disease, for example, only 3 to 7 days of protection will be brought to the potato or chip by the maternally derived antibodies. For infectious bursal disease, for bull disease, this protection is far more longer, for like 2 to 4 weeks. So that's important in the broiler life, that 2 to 4 weeks there's protection, but it will not be enough for the entire broiler life, as the broiler is approximately 6 weeks of age it will come. So you need to vaccinate the broilers also in their life, that they have some protection from the mothers. Then for fowl pox and avian encephalomyelitis, these protections are somewhat lower, 1 to 5 weeks and 3 to 8 weeks, so it's not necessary to vaccinate broilers against these 2 diseases. And then Merrick disease, which is also a very important disease, and broiler breeders are vaccinated against this, but Merrick disease vaccination in breeders gives no protection in broilers. So if you have problems with Merrick, specifically in long-living birds, you need to vaccinate these birds themselves as well to gain good protection. And well, something to keep in mind is that when you are vaccinating broilers against infectious bursal disease, like I told you, you need to take into account that they have maternal-derived antibodies, and that the time of vaccination is very dependent on the amount of maternally-derived antibodies. If there are still high numbers of maternally-derived antibodies against infectious bursal disease, then the vaccination can be less successful. So there are tools to calculate the optimal date for vaccination. Then our second mission was to gain good day-old chicks. The first one is protecting progeny by giving them maternally derived antibodies. The second one is to avoid vertical transmission, because diseases can also be brought from the parent stock to the young of the day-old chicks. And there's a whole list of diseases that broiler breeders can bring to the broilers itself. And then I talk about different species of salmonella, which are also very important in food safety. Then there's Mycoplasma bacteria, Polycepticum and Synoviae, who both can give problems. And then there's a whole list of viruses that also we can vertically transmit from the parent stock to the broilers. For example, avian encephalomyelitis virus, reovirus, avian mycosis virus, egg syndrome, avian influenza, and chicken anemia viruses. And perhaps there's even more. So we need to avoid that we bring diseases from the parent stock via the hatchery to the day-old chick. So how can we do that? We need to keep our parent stock flocks safe. So we need very good biosecurity. We need to vaccinate our parent stock, and we need to prevent stress, because the health status and stress of the parent stock is directly linked to the quality of day-old chicks that are derived from the hatchery. So what we can do is we use serology, we use blood samples to monitor the antibody status of different poultry flocks, flocks. So for example, if we want that the flock is absolutely clear of a disease, for example in the Netherlands, Mycoplasma thalassemicum, border breeders are free of Mycoplasma thalassemicum, we use serology and we see there's no antibodies against this disease, so we know there's no Mycoplasma thalassemicum in our breeders. Then we need to monitor for salmonella. We do this by SOX. We collect dust and feces, and we want to know if there's salmonella in the flock. And we can use spots for taking for Trachea or cloaca to check if there's any disease, and it can be also that there's diseases like that can be differentiated if it's a field infection or it's a vaccination. Then, why is this important? We need to avoid vertical transmission. Storage and incubation of eggs takes about 4 weeks. So 3 weeks of incubation and 1 week of egg collecting and egg storage. So this means that if we have a 3-week monitoring program, it gives us the time to keep vertical transmission from happening. Because every 3 weeks we check health status of parent flock, so we know that every 4th week we can deliver good day-old chicks. And if we find out that there is an outbreak of any disease, we can still separate or destroy breeding eggs, and we can do disinfection of hatchery, so we can monitor and we can prevent vertical transmission. And we can also do more biosecurity for neighboring farms and houses to prevent it from spreading to other regions. Well, how to set up a monitoring system? You have to choose your diseases. Now, well, you can see a list of diseases that you can check to monitor, and then you have to check the right tool to do the monitoring. So you can do serology, you can do PCR, etc., or bacteriology in case of salmonella is as well possible. And what is a setup of the monitoring system? It's very important to start with the start of production, that you start with a lot of information, so you know your starting point. You check for a lot of diseases, if there's good titers, if are the animals well protected, and in case of, for example, salmonella and Mycoplasma thalassemicum, are they ready? Are the birds free of these diseases? Then bi-weekly, every 2 weeks, you need to check for salmonella. For salmonella is so important in food safety, and also maybe in day-old chick health, in case of salmonella chloride and pollinaria. You do SOX every 2 weeks just to check if there's salmonella in the flock, and you want to absolutely keep them free from salmonella. And this is very important in the Netherlands, that if you find salmonella in your parent stock, your flock will be culled, and that's also a very economic big loss. Then every 3 weeks, and this is in case in a situation that you have more Mycoplasma endemic, you need to check every 3 weeks for MS and MG. In the Netherlands, where we have flocks that the parent stock are free of Mycoplasma thalassemicum, we check every 12 weeks our broiler breeders by blood collecting and serum analysis. And then you do every 8 weeks, you have to check for salmonella chloride, pollinaria, and even leukosis virus, also via PCR and serum. Well, then when we come to the end of my presentation, what we do, we vaccinate parents. The parents have antibodies against a number of diseases, and these body antibodies are transferred to the chicks to provide protection in early life. But automatically, does this mean that high MDAs mean better protection in the progeny? Well, you might think about it for a while, but of course, no, this is not the only thing. High levels of MDAs are very important, but the health status of the parent flock is very important as well, and it contributes to this a lot. But we will discuss this more tomorrow. So, the conclusions of the health aspects of our parent stock. We've then vaccinated our parent stock to protect the flock itself, but also the offspring and progeny. And the parent stock's health is directly influencing progeny. We need to have good biosecurity for preventing diseases to be transmitted from the broiler breeders to broiler chicks, and you will need to obtain this goal to achieve good day-old chicks, to monitor the status of your parent stock. And you need to check for different diseases in the different for different diseases to check if there's any disease in your flock that might influence the quality of your day-old chicks. Well, I will want to thank you a lot for your attention and for listening to my presentation. Tomorrow I will be back and tell more about day-old chicks, and I hope it was very important for you. Thank you for your attention.